for with Amazon and do a lot of the official AWS training courses for them. Spent quite a bit of time in the BBC doing that, and I was with the BBC last week actually, and then quite a bit of time. I was involved in a startup for a while, doing food deliveries, another long story, CTO for a food delivery business, competing with Deliveroo. And anyway, more recently, as I say, we do a lot of machine learning and AI type technologies and Python and so on. And this little session we're doing now, I've delivered a variant of it quite a few times online in the last few weeks. So, and I'm based in Bristol in the UK. So if we, and if you've got any questions as we're going along, feel free just to unmute your microphone and just ask, just speak up as we're going through. It'll probably make it more interesting as well. So just any question you like, and if it's going to come up later, I'll just say, if it's something that's, we'll pick it up at the end or offline afterwards or something, but just ask them as we go along. We'll try and build in some time at the end for questions, but we've got an hour, haven't we, roughly, just under. So we'll build in a little bit of time at the end as well. But if you've got a question as we're going through, just unmute and ask the question. Yeah. So if we look at machine learning, why an AI, why is it now suddenly become such a big deal? It seems to be in the media and in the IT media. And if you work in some of the IT tech companies and companies with a lot of tech in them are starting to explore seriously AI and ML, and some of them are using it quite successfully and have been for a while. And there's probably three things that have come together to give us the ability to start using this stuff, make it accessible and so on. One is the fact we've now got high performance cloud platforms available to us, like Amazon. Yeah, so we've got AWS, but there's Google Cloud as well, and obviously Azure. And those platforms give us access to high power computing resources that historically would have been the privilege of very big businesses with a lot of money, or universities, and only the top universities who'd have the computer resources. I remember visiting the high performance computing center at UMIST in Manchester years and years ago now. And even more recently, Cambridge University at the Supercomputer Centre just last year, I think it was. But to get access to those kind of places is difficult. Whereas now, the reality is those kind of locations, the need for them is less in a sense, because you can do it yourself. You can just use the cloud, use Amazon, do stuff in there. So you've got these high performance resources available to you to do some pretty full on complex computations. Second thing is we got access to large amounts of data. So if we think of, just think of a couple of industries, the computer gaming industry, for instance, the game Fortnite, they store, I think it's between 2 and 3 petabytes of data every month. They store that. So, I mean, goodness knows what's in there, but it's 2 to 3 petabytes of data anyway, every month is put aside and stored. Yeah. If we take the insurance industry, if you think of those black boxes, I mean, one of my kids, we've got 4 kids, and a couple of them are driving. When they first learned to get the good insurance, they had a little black box that had to go in the car, tracking all their, the way they were driving and all this kind of thing, and the time of day and all the rest of it. Well, all the data from those devices, suddenly you've got loads of data on your customers, lots of it, all the data points. So you've got massive amounts of data. And then thirdly, you might have the data, you might have a computer, a computer in the cloud, you've got lots of data, but how on earth do you actually process it? It just seems like, well, that sounds very complicated. And it can be, but there are frameworks and programming environments and technologies around to make the interaction with that data and that compute resource relatively straightforward for a semi-competent programmer or even an analyst. You don't need to be a computer programmer. To give you an example at New Reader, we've trained hundreds, literally hundreds of financial analysts in Python. In fact, we're training some at the moment. So we've got hundreds of these people going through courses with like 400 people on at once, learning Python. They're not programmers. They never want to be programmers, but they want to learn Python so they can do this kind of stuff. AI, machine learning, looking at financial markets and all the rest of it, trying to work out where to invest and not to invest, etc. So you've got these three things have come together. You've got high performance computing, you've got the data that you need to do some learning from. We'll talk about what that means in a minute. And then you've got the technologies and frameworks to make it accessible. And it's no longer sort of PhD maths territory. It's actually accessible to mere mortals like me you can make some sense of it. You know, my degree, I've got a degree, but it's in biochemistry. It doesn't really naturally lend itself to this kind of stuff, but it doesn't matter because you can use it and take advantage of these frameworks and platforms that are now available to us. So let's look at what it is, machine learning, and then we'll look at what AI is as well. So machine learning, if we start with a question, how would you define machine learning? In fact, over to you. You can unmute. Yeah. How would you define machine learning? You know, I want to have a stab. You can't really be wrong because it's just how you would define it. So it's up to you what you say. What do we think? I can see lots of red mute buttons from here, just on my screen in front of me. You just need to unmute. Anyone want to just give it a go? We might have to play microphone roulette. I don't know if you can do it with Zoom, actually. I'll just normally I use different technologies normally, and you can just unmute someone and get them to answer. I don't know if you can do that with Zoom. So anyway, machine learning, if we want a definition, it's the ability of a machine to learn something from data. There's a simple definition, straightforward. Yeah, you're training a machine to learn something. Notice the last bit, from data. One of the key, remember we said those three things, you've got the data, you've got the compute. You do need the data. Without data, you can't do machine learning. So if you've got no information, if you're thinking of applying this stuff in your business, but you've got no information anywhere, you ain't going to be doing much, because you need the data to be able to learn. Unless you can rely on data sets from elsewhere, you won't be able to learn anything because you need the information. So data is key. But basically, machine learning is the ability of a machine to learn something from some data. Yeah, so a machine could learn, there's lots of examples, but it could learn to play a game is an obvious one. Chess, I remember I was in Dublin actually not that long ago, and doing this stuff, and a guy in the class, he was working with IBM when they did the computer, the first computer to ever beat a grandmaster at chess. And so he was involved in that. It's just talking about it. It's fascinating to listen to him talking. But if we fast forward to now, just a few years ago, computers are now winning at Go, which is a much more sophisticated game than chess. The machine could learn how to play it. It could learn how to recognize images and faces and things like that. Yeah, and we'll see an example of that later. It could recognize, if we take insurance again, damage to a vehicle. Yeah, so it could see, maybe give an estimate of the cost of the damage to a vehicle. Yeah, it could look for fraudulent behavior. Yeah, so if you're in a financial business or a business with fraud potential is always a risk, you could have AI detecting that fraudulent behavior. Or medical conditions. It could spot, conditions from an X-ray, and they're already using that, aren't they? So using machine learning, we can identify, if you've got a culture, this is my territory now with biochemistry degree, but you've got a culture, you can recognize from what's growing on it, is that what's growing on this culture, is that the fungus you think the person's infected with, or is that the virus you think they've got, or whatever it might be. Yeah, we can use machine learning to learn how to deal with those kinds of issues as well. A more formal definition of machine learning could be this. This is a commonly cited definition of machine learning. And if you've looked into this kind of stuff before, you might recognize this. This is fairly standard. It was from 97, so it's quite a few years old now. But basically it says machine learning is said where you're learning from a particular experience, or learning from experience E, with respect to some task, T, so there's something you want to do. And the performance is measured, yeah. And if the performance of the task measured by the measure improves with experience, in other words, the performance should get better. So if we take a real concrete example of this, you could take facial recognition. So learn from looking at lots of images of faces. So the machine looks at loads of faces with respect to learning how to recognize people and measure how many are identified correctly. So it should be identifying people, identifying faces. And if the recognizing of people improves with experience, because in theory, you should get better and better at recognizing faces. So the machine learning is where the machine learns from what it sees. Yeah. So we can train a machine basically. So there's Go, there's the game that we talked about. The machine is learning. It was March 2016 where the machine finally for the first time was able to beat like the grandmasters, or I don't know what you call them in Go, but the people who are really good at Go, anyway, whatever the technical term is for them. Yeah, the computer in 2016 beat them, yeah, through what it learned in machine learning. So machine learning then fundamentally is just a machine learning. It's simple as that. Learning from data though, and then getting better at some kind of task. So that's ML, or machine learning. What about the AI side of things? Artificial intelligence, if we think about what that is, yeah, it's once the machine has learned something with machine learning, it can then do something with that learning, apply what it has learned. The intelligence, it's artificial, but it's intelligent. It's then applying what it's learned. So the machine learns how to play Go. It then wins at Go when it plays someone at it. Yeah, or the machine learns how to identify certain medical conditions, and then you can apply the AI. In other words, you use that, they call it a model, you know, what you've worked out how to solve a particular problem or identify something, that is then applied. That's like the intelligence, if you like, where you're applying the AI to solve a specific problem. Again, a formal definition, if you want one, it's the ability of a computer or other machine to perform those activities that are normally thought to require intelligence. So artificial intelligence, it is where you're getting a machine to do something that normally requires an individual to do it. Yeah, so it normally needs an individual to do that, but and someone with expertise as well. Yeah, so you're actually replacing high expertise capability of a human with a machine. So if you think, you know, could my job be done by AI? Well, does your job require intelligence? And is there an element of repetition to it where you'd be looking, is this fraudulent? Is this fraudulent? Is this fraudulent? Is this fraudulent? You're applying your knowledge and experience. Is this fraudulent? Is this fraudulent? You're looking at car damage. You're saying, how much is this? How much is this? You're looking at the damage of the vehicle. You can probably estimate it just almost by looking sometimes. So yeah, I know that's going to be at least in a ballpark. Yeah, looking at the vehicle, you know what make it is. Oh, they're always expensive. You apply that knowledge, anything like that, where you're applying that kind of expertise and background knowledge to solve a problem. Yeah, like my uncle's a radiographer, so you're looking at X-ray. Oh yeah, they've got this. Another X-ray. Oh yeah, that. Anything where they're applying the knowledge and so on. That's where AI comes in. And the benefit of applying it, you might think, well, that's my job. Is that gone then? Not necessarily, and no, probably, because actually you can then focus on the edge cases, the ones that do require a little bit subtle, and frankly, the machine can't deal with it. Yeah. So for those edge case situations, still use the human, but for the stuff that's, you know, actually relatively straightforward, if you can apply that intelligence, then we can use AI to solve the problem. To give you an example, one company I was working with, they'd written AI to read a business requirements document and spot issues with the document. Now, that's a really boring example of AI. Normally people bang on about this kind of thing like I am. Oh, playing chess, playing computers at games, medical stuff and all the rest of it. All very sort of facial recognition, blah, 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 all quite exotic. And you think, well, none of that's much use to my company. When do we do facial recognition? You know, we don't. Yeah. But actually, this place, they'd used AI to read specification documents and spot ambiguities and problems and issues with the specifications. So, you know, there's a job that requires skill, yeah, expertise to read a requirement specification and look for ambiguities and errors in it and so on. They've got a machine to pick up a lot of that stuff. And obviously it's not going to pick up everything, but it will pick up a lot of the problems, and they're using it at the moment in the organization. So it's just an example of where we're seeing AI in practice. And there's a good example online of Google. You might Duplex. This has been in the news recently, Google Duplex. But Google Duplex is the AI from Google that can book appointments and things like that for you, making phone calls on your behalf, and it sounds very realistic. So let's see if we can get this to work. So living on the edge, this is.
The progress of the assistant. As I said earlier, our vision for our assistant is to help you get things done. It turns out a big part of getting things done is making a phone call. You may want to get an oil change schedule, maybe call a plumber in the middle of the week, or even schedule a haircut appointment. You know, we are working hard to help users through those moments. We want to connect users to businesses in a good way. Businesses actually rely a lot on this, but even in the US, 60% of small businesses don't have an online booking system set up. We think AI can help with this problem. So let's go back to this example. Let's say you want to ask Google to make you a haircut appointment on Tuesday between 10 and noon. What happens is the Google Assistant makes the call seamlessly in the background for you. So what you're going to hear is the Google Assistant actually calling a real salon to schedule the appointment for you. Let's listen.
So how can I help you? Hi, I'm calling to book a woman's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second. Sure, what time are you looking for around? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service she would like. What service is she looking for? Just a woman's haircut for now? Okay, we have it 10 o'clock. 10 a.m. is fine. Okay, what's her first name? The first name is Lisa. Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks, great. Have a great day. Bye.
That was a real call you just heard. The amazing thing is the assistant can actually understand the nuances of conversation. We've been working on this technology for many years. It's called Google Duplex. It brings together all our investments over the years in natural language understanding, deep learning, text-to-speech. By the way, when we are done, the assistant can give you a confirmation notification saying your appointment has been taken care of. Let me give you another example. Let's say you want to call a restaurant, but maybe it's a small restaurant which is not easily available to book online. The call actually goes a bit differently than expected. So take a listen.
Yeah, may I hear you?
Hi, I'd like to reserve a table for Wednesday the 7th.
For 7 people?
It's for 4 people.
4 people? When?
Next Wednesday at 6 p.m.
Oh, actually, we reserve for like after like 5 people. For people, you can come.
How long is the wait usually to be seated?
For when, tomorrow or weekday or?
For next Wednesday, the 7th.
Oh no, it's not too busy. You can come for 4 people, okay?
Oh, I gotcha. Thanks.
Bye bye.
It's pretty amazing, isn't it? Some of you might have seen that video before, but it's a remarkable example of AI and machine learning in action, where you see the computer making the phone call and dealing, especially at a restaurant, and dealing with the confusion and the complexity around the lady getting the dates wrong and the time wrong and all the rest of it. But still, it was absolutely fine, and it was able to make the appointment. So it's just a really good example of AI in action. Yeah. So what does an AI project actually look like? Yeah. What does an AI project involve? If you're in, I don't know, many of you perhaps work in technology or in companies with technology and so on, or you work with, you've got teams that you work with or staff that you have to manage. And if they're doing this kind of thing, where does their time get spent? What do they actually do? Well, essentially, you could divide it up into 4 phases if you're doing this stuff for real. First is you've got to get all the data. Remember we said you need data. Without data, you're not going to be doing very much. So we acquire the data. Once we've acquired the data, often we need to spend some time getting it into a format and a structure that's going to make it easier and quicker and more efficient and so on to do our learning. So we might need to do some preparation on the data. Once we've got all the data ready, we can then do the learning. So there's our machine doing some learning. And once we've done the learning, we can then actually solve some real problems using the AI. Yeah, so we've got the problem solved, so then we so we've got the machine learning done, so then we can actually solve some issues. In terms of how much time we spend on those things, the amazing thing, I think, is if you look at, I don't know if you can see this very well, hopefully you can, but you've got 20% or 19% here, that's collecting data. So you spend a fifth of your time just finding the data. And then 60%, what's this huge one? Cleaning and organizing it. So basically you spend 80% roughly of your time just getting the data ready. Yeah. And then the last 20% is the machine learning and the AI, the easy bit, if you like. Yeah. Once you've got the data. Sorry, it's my phone ringing. Yeah. So that would be the kind of process you would go through. Yeah. In terms of time. So if we take a real example, let's look at a concrete example of this stuff happening. What we're going to do, we're going to look at two concrete examples of this technology. So the first one is we're going to look at the AI. So we're going to look at where the machine learning has been done, the data, all this first three stages have all been done already. Someone else has done them. We don't need to worry about it. We're just interested in the AI bit. And the cloud providers have services that can give you the AI bit kind of on a plate. So they've done the machine learning, they've done all this hard stuff or more sort of long-winded stuff, and just give you the ability to do some artificial intelligence. So let's look at a couple of examples. So here's one, a couple of photos here. So we've got a person on the left, yeah, here, and the question we want to ask is this person on the left in this photo on the right? So we just want to know, is this person here in this group photo on the right hand side? Yeah, it's actually a family photo of us when we're on holiday, and this is the Mrs. Sarah. So anyway, how do we find that out? Well, here's, sorry if it's code, yeah, it's Java code as it happens, but it could be any programming language. Don't worry about the detail. I appreciate you, perhaps not all, or perhaps none of you are programmers. It doesn't really matter. Just count the lines even. Just count the lines of code. How complicated is it to do facial recognition? It's 6 lines of code. And the last line is just printing out how confident you are. So the last line isn't really facial recognition, it's just printing something. So you can even say it's 5 lines of code. It's that easy. This stuff is so easy now. I was doing an apprenticeship scheme in London last summer. I had a group of 18-year-olds teaching them Java. And on the last day, we just did facial recognition for the last day in the afternoon for a bit of kind of light relief, to apply the Java to something a bit more interesting than libraries and the other boring stuff you do sometimes on apprenticeship courses. So anyway, we just did some facial recognition. So you've got 18-year-olds doing it. You know, it's very, very straightforward. And this is using an Amazon platform called Recognition to do it. Yeah, it's kind of one of the things they talk about with the cloud providers is they democratize technology. So stuff that historically would have been only possible by big companies and governments is suddenly possible by you with your cloud account. You know, so you could set up a cloud account tonight and do some facial recognition, 6 lines of code, boom, done. Very, very easy. It's democratized. This kind of stuff used to be, you know, for governments. Now it's, well, you could do it, I could do it, anyone can do it. Very easy. If you want to see an example, and you can see this recognition stuff working for yourself, you can try this out now. There's a link there. You can use your if you're feeling techie and all that, you can get your phone out, just do a barcode, QR code reader on that. It'll take you straight to the URL. If I just click on the link here, this takes me in straight into the web page. Here it is. Yeah. So what I can do is upload a picture. So click on this, just find a photo. Let's just grab a picture quickly. Camera, just find any old picture. There's one. Just take one quickly. There we go. So we've got a picture. Here we go. And it's now.
Hi, my name is Polly. In this picture, I see one face. The first face is a happy male between 2 and 8 years old. I think I also see clothing, sleeve, couch and furniture.
Yeah, so basically it's looked at the picture and given us some data about the picture. You can try it. Go to the web page, upload a picture of yourself or whatever. It doesn't even have to be a person. You can upload a picture of anything, yeah, and get it to tell you about the picture. We're actually using 2 pieces of AI here. One piece of AI is the one that's giving you all the definition of the picture. Yeah, so it's telling us all about the person in the photograph. Yeah, and then I don't know if you heard it, but it was speaking it out loud, reading this. That's another cloud service for AI called Polly. I don't know if you heard, my name is Polly. Polly is the name of the service that does speaking. Yeah, so it's another service from the cloud provider. So we're using two there, relatively easy to use, just a bit of code in the web page, and we're taking advantage of these Amazon, in this case Amazon, but it doesn't have to be Amazon, these Amazon services. Yeah. So that's recognition. Yeah, that's the recognition service that you can use for recognizing all sorts of things. So you can upload, here's another example. This is from Amazon themselves. So you can see we've got a photo here of someone on a mountain bike. You know, it's picked up the fact it's a person, it knows it's a mountain bike, it knows it's a rock, there's a crest of a hill, it knows it's outside, etc. So it gives all that data about the picture, just like we saw with my little photo upload thing. Yeah, so we can use services like this, yeah, to apply some artificial intelligence for us. Yeah, and that particular one is called recognition from AWS. Yeah. Another commonly used service for AI would be for virtual assistants, yeah, or chatbots. Yeah, so we can create a chatbot as well with that. We won't do this now, but it's actually relatively easy, or very easy actually, just to create a chatbot. Yeah, and these chatbots again use some natural language processing to work, which is a technical term basically for working out what someone's on about. So your natural language processing, your NLP, so you can work out what the user is trying to say. And actually, if we use the Amazon one, which is what this is talking about, Lex, there are others obviously. Google have one called Dialogflow. Microsoft have one. There's others. IBM, I think, have one. There's a few. They all basically do the same thing though, and they all work in a very similar way. The Amazon one, Lex, basically is the same as Alexa. So if you've got an Alexa device, you know, the Alexa, I've got one here. You know, this is a small one, but you know, the Alexa devices that you say, Alexa, what's the weather? Alexa, you know, and all that kind of thing. It uses the same technology, and it's natural language processing. So when you speak to one of these Alexa devices, it's doing natural, on the back end, there's natural language processing going on to work out what you said and what you meant. Yeah, and that same technology can be applied to a chatbot as well. So you can create these service agents or chatbots, yeah, using Lex or Dialogflow and so on. But they're really good for businesses. They save them, you know, a ton of money, where you've got people phoning up, I forgot my password, phoning up, oh, I can't get into my account, and all this kind of stuff. Rather than phone up, you just type in a chat message. You don't even need a human there. Yeah, and initially some of the call center staff, one of the places I was working at recently, they were saying the call center staff were quite nervous in a way about these. Well, they're going to take our work away. But actually, what in reality happened is the call center staff were just dealing with the slightly more interesting calls. So they weren't dealing with, oh, I forgot my password, that kind of stuff. That was all being dealt with by the chatbot. And then the call center staff started to get the more interesting and varied work coming through to them in the call center, as just an example. So service agents or chatbots or Alexa skills actually would be the same. They're all using natural language processing technology and AI, if you like, to facilitate this kind of thing. Yeah, to give us we're using AI to facilitate interacting with our customers in this particular case. So if we now, so that's AI. We've mentioned two examples of AI. I could show, actually, I'll just show you the chatbot. We've just about got time looking at my watch there. So I'll just show you how easy they are to set up. We don't all necessarily need to do it, but I'll just show you now if I can find the link. So if I just go to it, just to show you how this works. So this is going to take me into the Amazon interface. So I'll just quickly sign into it. So this is the Amazon console. So this is for AWS. consoles for Google as well and Azure. They're also not trying to plug Amazon here. This isn't sponsored by Amazon or anything. Just happen to be using it because it's nice and easy to show you. So this is the interface for AWS. So if you were doing cloud computing, if you wanted to launch cloud servers or do some recognition even, or Lex or Alexa skills or whatever, basically, this is the interface. One of the ways basically you can interact with AWS is through this web console. So I'm just in the web console. So let's just have a look at how you can create a chatbot. So I'm in the chatbots area, yeah, bots. So I can just, you can probably guess what I need to do. Yeah, so click create. And then conveniently, there are some demo chatbots I can create. So I'll just get one really quickly. Yeah, so I'm going to go for a order some flowers. Yeah. So order flowers. So we'll call it order flowers. That's just the name of the chatbot. And if I just scroll down, I just need to choose one other option and then we're good. So it's just a thing you have to do for Amazon anyway, to say that your chatbot isn't going to be used by children, because then there's some legal requirements in the US if it is. So I just click create. And it gives me a chatbot. And the way these things work, you might think is essentially the user, say you want to order some flowers, that's referred to in Google and Amazon, actually use the same terminology, that's referred to as an intent. It's the intent of the user. I want some flowers. I'm going to a chatbot to order them. That's my intent. So if your intent is to order flowers, then in this example, there are 3 things that you need to somehow tell the chatbot. You need to say what flowers you want. You need to say what date you want them, is it? Yeah, what day you want the flowers and what time do you want the flowers. So you need to say what day, what time, and what type of flowers. Those 3 facts are referred to as slots. Yeah, and this is exactly how Alexa works. If you've got an Alexa device, so you're one of these voice assistant things, if you think about the way you use them, you ask it to tell you something, say, tell me the weather. It might say, what city, so that's a slot. The intent is you want to know the weather. The slot is the city, where, which place do you want the weather for? Yeah. So you've got these different things to fill. So here we've got the slot. And then we see these sample utterances. Now this is where the AI comes in, because we need to trigger this chatbot to know that, you want to order flowers. You're not returning some flowers. You're not complaining about some flowers. You're actually ordering some flowers. How do we know you're ordering some flowers? Well, you'll say in the chatbot, I would like to order flowers. Or will you? Maybe you'll say, I want flowers. Or maybe you'll say, give me flowers. Or you might just say flowers, exclamation mark. I don't know what you're going to say. Yeah. So I need to put in some sample utterances, the kinds of things you're going to say which mean that you want some flowers. And the more of these I put in, the more accurate it'll probably be. But I don't need to put them all in word for word. And this is where the benefit of the natural language processing from Amazon comes in. So when you type something in the chatbot, which isn't one of the samples, but it's a variation of them, AWS, Amazon, are clever enough to look at them and think, oh, you want flowers, I can tell. I know it doesn't say, here we've got, I would like to order some flowers, I would like to pick up flowers. If I actually typed, I would like flowers, hopefully, we'll find out in a second, it'll be clever enough to know that's what I meant, even though it wasn't one of the standards, because it's using natural language processing to work it out. Yeah, so I'm just going to create it as is. So I'm going to test the bot. So I can go in here, there's the test area. And obviously normally you'd be fiddling with your chatbot and changing these things and so on. So if I just type, I would like some flowers, let's see if it's clever enough to pick it up. It is. Well, that wasn't I would like some flowers wasn't one of the samples, but NLP from Amazon was clever enough to work out what you meant. Yeah. So then it asked me what type of flowers. Now there's no intelligence in this thing at the minute. I could type anything here. I could type, doesn't even have to be a type of flower to be honest. But if I'll stay on task, roses. And then it says, what day do you want them? I think you can say a day. Yeah, pick up the roses. At what time? Yeah, so it's worked out what the day is. So I've said Friday, so it's worked out that what the next Friday would be. Then it's what time, so I can now say 2 p.m. So I want the flowers at 2 o'clock, and it's worked out 2 p.m. is 1400, obviously. And then it's got the date 17th of April, which is the next Friday coming up. So that's an example of a chatbot. Now, obviously here you could be building in your own types of things, that intents, different intents. I will spend some time with the BBC team who do the voice, play Radio 1, play the BBC radio player essentially for Alexa, which is basically the same as this. So, the slot would be what radio station you want to play, basically. I want to play Radio 1, please play this station, etc. So that would be the slot. But you build it up in a very similar way, even though it's spoken instead of being typed in. So that's a virtual assistant or chatbot. So we've looked at some examples of AI, the artificial intelligence. So we've seen natural language processing one, so looking at text, and we've seen a image processing one, the facial recognition. But what about machine learning? What about if we just jump back? We've basically been on the box on the end, the green box on the end, AI. We've just sat here. What about these other boxes? Doing the machine learning. So let's have a little look as we finish off in the last couple of, we've got 20 minutes basically, so just under, we'll try time questions as well. So let's have a brief look at some machine learning. This is the slightly more complicated bit because you've got to do some coding of some kind here. This is where those financial analysts I was talking about earlier were learning Python. Most people use Python for this stuff. They don't all use Python, but it's a very commonly used technology. So machine learning, this is not a simple bit, as I say. This is where you're actually doing the algorithms and all the rest of it. The most popular programming language for doing this is Python, and actually now the most popular programming language in the world, as Jeremy Clarkson would say, is Python. It's now above everything else. There's a nice little video on YouTube if you're interested. Programming language history, popularity. There's a video of you can see all the different languages going up and down over from 1960 something up to 2018 or whatever it is. And Python is now right up there. And this technology is one of the main reasons why, because Python is so accessible for people who wouldn't say their day job is programming. So if your day job's not programming, Python's a relatively straightforward language to pick up. Certainly one of the easier ones, on the easier end of programming languages that are around. And the way you often write the Python is in things called Jupyter notebooks, which again, you might have heard of if you've hung around technologists or you are a technologist yourself. Jupyter notebooks basically let you write code in like a web page. In simple terms, that's what it does. So you type your programming code in, but you just do it in a website. So whereas if you're a programmer or programmers, the caricature, headphones, cupboard, computer, coding in some kind of matrix kind of green thing, whatever your caricature of what programmers are, this is not it. This is a web interface. You type your code in the web page. You can put normal sort of web page type things around it as well, so other people can view it. You collaborate with others, and you basically put the code in to get your algorithm put together. It's part of a suite of technologies called Anaconda. Anaconda is a distribution of lots of machine learning technologies, and Jupyter is one of them. So if you want to install it locally, you can just install Anaconda. So if we take an example of this stuff in action, we're going to look at a notebook that does sentiment analysis. So it's going to be some natural language processing on movie reviews. So I don't know if you've come across these, or I'm sure you've come across these films. So if we take Charlie and the Chocolate Factory, probably the best film of its sort since The Wizard of Oz. It's everything that family movies claim to be, but aren't. So positive movie review. On the other side of the spectrum, we've got that film Cats, which everyone seems to think was terrible. Cats, you can't believe what you're looking at because it's so hideous to behold. So we've got some reviews that are positive and some reviews that are negative. In fact, we've got 2,500 reviews that are some are positive and some are negative. And what we'd like a machine to be able to do is do what's called sentiment analysis. You may have even noticed that was an option, a tick box, in the Lex console earlier. Sentiment analysis is very useful. It allows businesses to tell, basically, was this person happy or not? Were they happy with the service we provided or not? We can read all the call center transcripts and see how many people are basically happy and how many aren't. We should be able to work it out from the transcript, but how? NLP, natural language processing. We're looking at movie reviews. Here's a review. Did they like the film or not? Yeah, we just like to know if they liked it or not. So positive and negative reviews. So we're going to look at a Jupyter notebook that tells us this. If you want to look at the notebook, I'll give you the URL. Let's put it in the browser. It's ml1.conager.com:1234448, and that should come up. Press enter. It's trouble, you can't see what you're doing. What's going on there? Oh no, it can't be reached. It's 8888, isn't it? Go there a second. I put it on this other machine earlier. Oh no, it's gone off. What's going on? Oh no, that's my screen share. Sorry, just bear with me a minute. Two computers on the go here. I was looking at this literally a second ago. ml1.com. Oh, it's switched itself off. Let's just switch it on. There we go, it's coming. Yeah, so it's ML, let me put it in the chat while we're just waiting for it to turn on. Chat. Where's chat? I just want to chat message. It's not letting me. I'll put it in the other chat on the other machine. Bear with me. There we go. ML1 dot. There we go. I'll put it in the chat for you just on my other computer. And then if you want to visit it, you can just have a look. And then it prompts you for a password, as you can see up there. That's secret123. So not very secret. I'll put that in the chat as well, just so you can see it. There we go. So that's the password. So you can put it on your screen if you want to. So I just log in here. There we go. This is Jupyter. So Jupyter notebooks, and we're interested. There's only one notebook in here: Deep Learning Movie Reviews. So if we click on Deep Learning Movie Reviews, and it basically walks you through what's going on. Now, I'm not going to go through the detail of this code. We haven't really got time to anyway, and you probably wouldn't thank me. But we're just going to look at it in very briefly in terms of what's going on. So when people talk about machine learning, you think, what on earth is it? This is what it is. You're looking at it now, so we can actually demystify it. Remember I said at the beginning, we try and demystify this stuff. So basically what it's doing in this code is it's getting some movie reviews. So the first bit of code is downloading a couple of files. You can see if you're looking at it, you can see it's downloading some files. This is what we call an example of supervised learning. You might have heard that term before, which basically means you're going to give it some movie reviews that have already been marked as good or bad. And it's going to learn from those. So our good ones contain the word good and fantastic and wonderful, and bad ones contain words like terrible, awful, ridiculous. So you basically train it with example data, so supervised learning. So we're going to download two sets of reviews, one where we know if they're good or bad, and one where we don't know if they're good or bad, and we want the machine to tell us if they're good or bad. So we download the data, that's the first bit. We then clean it. You'll hear a lot about in machine learning about data cleansing. Remember the second box along out the 4 boxes? First box was get the data. We've kind of done that with some code in there, to download something. Second box, get some data. So we retrieve, the second box is to clean the data. So we need to clean up the reviews. So in the movie review files we download, there's HTML tags and punctuation and funny characters and all the rest of it. Get rid of that. So we clean the data out. Then once we've cleaned the data, we then use an algorithm on it. And there's lots of different machine learning algorithms for different types of machine learning. And that's where it can get quite technical. It's knowing which algorithm to apply and how to apply it. Luckily, Python gives us libraries to make it easier to use these algorithms. So we don't need to be mathematical geniuses to do it. But nevertheless, you do need to know which algorithms would make sense. But then finally, once you've done that bit, so that number 3 is the tricky, clever bit. Remember, number 2 is the bit that in a real situation often takes a long time. You know, cleaning the data, 80%. Remember, 1 and 2 there would be 80%. Number 3, you know, in terms of how much time it takes you, although it's technically quite complex, or can be, you're working out which algorithms and so on to apply. And then finally, number 4, we can test our system to see if it's doing a good job. Yeah, so the mover reviews we're using, some of them, we've got 2 data sets, remember. One data set where we don't know whether the reviews are positive or negative. So you've just got an idea of the review and then the review itself. And then the other set where we can learn from it, where we've actually got the sentiment analysis done. So notice the column in the data is called sentiment. Yeah, it's either 1 or 0. 1 is good, 0 is bad. Yeah, and that's the data that the code is looking at. If you want to see a detailed walkthrough of that notebook, by the way, there's a video there where I just spend a bit more time going through the various sections of the notebook. So for those of you that like to walk through the notebook, you know, with a video and just see it in explained, then you can see it on that link there. And the actual notebook itself you can download as well. There's a link to the notebook which you can grab it from as well. So I'll give you these. iTag and SkillsNet will give you a link or whatever for these slides, so you can get them. So how does all this stuff affect your day job? Yeah, where will job roles change? Where might this stuff make a difference? We've already mentioned some of them. So in the medical area, that's ripe for AI to start to help us. In the technical area, we've already mentioned, you know, reviewing specifications. So reviewing documentation, reviewing specifications. In HR, you know, filtering out CVs. You put a job out there, you get shed loads of CVs in. You want to do a coarse-grained initial filter. Maybe AI could be applied to filter out or filter in the CVs you want to look at. If you think about, again, a more technical one, infrastructure management. If you've got a large infrastructure to take care of and you need to sort of change dynamically the way the network is operating depending on types of traffic. So if a lot of your traffic is video streaming, for example, you might want to change the network configuration, but then the traffic shifts and it's no longer video streaming, it's something else. So you want to shift your network setup. Well, again, AI can be used to do that, dynamically changing the configuration and setup. Or fraud detection would be another one, as we've said. So you can use AI to look for fraud detection. On my Amazon account, I have a service called Guard Duty, which basically picks up unusual activities in my Amazon account. So if anything strange happens, this is the cloud account, not the shopping one, but if anything strange happens, well, Amazon deems strange, something I don't normally do or nobody normally does in my account, it flags it. Yeah, it's applying AI to learn from how I normally operate the account and what it should expect to see in that account. And that's, I mean, that's a cloud example, but it could be financial, it could be anything. Yeah, or insurance, yeah, calculating risks, premiums, and things like that using AI. Essentially, as I said at the very beginning, any job that requires expertise, yes, if you're in a role that requires expertise, where that expertise is based on your experience and knowledge, and you're solving a problem, it may be a similar kind of problem over and over again. When you're in that kind of ballpark, yeah, that's the kind of area where AI could potentially be introduced. It could save you a lot of time, save you a lot of hassle, minimize errors, reduce risk, and reduce cost as well. So that'd be the kind of job roles that would be affected the most, generally speaking anyway, by artificial intelligence. Now I want to leave some time for questions. So what have we said? We've basically looked at what machine learning is. You know, the simplest definition, it's machines learning. It's as simple as that. But they learn from data. Once a machine has learned from data, we can then use that learning with some AI. Yeah, it's a slightly artificial distinction what I've got there, but it just makes it easy to follow. Yeah, so once we've learned some stuff, we can then use that learning with some intelligence, if you like, some artificial intelligence based on what we've learned. So is that person in that photo? Is that image outside or inside? etc. Yeah, we can use the learning with some AI. We've talked about how an AI project works, from a technical point of view, just very high level, obviously, but in terms of time, spend a lot of the time just getting the data sorted out and getting it all ready to do some machine learning. And we've seen some examples of actual AI. So we've looked at, just very briefly, obviously, how you can create a chatbot in Lex, which uses natural language processing. And then we also saw some machine learning with the Jupyter Notebook. And if you're interested, you can have a look through the link. I've shared the link. It will be up and running for a little bit longer. You can see the code in there using Python that actually does the machine learning. And then finally, we just talked a bit about job roles. We've said it a bit as we've gone along, really, but any kind of area where you've got expertise and you're trying to solve problems, potentially that can be augmented and facilitated through artificial intelligence and machine learning. Now, we've got 5 minutes. So any questions you want to ask on what we've looked at before we wrap up? Just unmute and ask away. I can't hear any questions. I don't know if it's, just check my speakers are on. Can you type it in the chat potentially? I can just about see it from here. No, well, I think we're all done then in that case. So thanks for giving up some of your day for this session. Hopefully you found it useful as we've gone through. We'll sort out how we get the slides to you, and we'll be able to upload them and send you the link or whatever, and you'll be able to download them, and you'll have those links in there. My email, if you have any questions, I'll just put it in the chat. Sorry, the chat window's in a funny place, so I'm just going to have to move. So this is my email. Just pop it in here. There you go. So that's my email address. If you have any questions that occur to you afterwards when we've all disconnected, feel free just to ping them over. But otherwise, enjoy the rest of your day. I'm going to hang around just for a couple of minutes in case any of you have any questions, just as we finish. But otherwise, feel free to drop off the call, and we're all done.
Thanks, Nick. That was great.
Okay. Hopefully it was useful for people. There wasn't any questions or anything, so.
Yeah, no, I was just looking there in the chat as well. There wasn't anything there either, so. But,
yeah, it seemed to work. The technology worked, didn't it?
Yeah, everything worked fine. Yeah, it did. Yeah, everything worked fine. I made you host. I don't know if that was necessary, but yeah, worked fine.
Yeah, no, it was good. I think I did need to be host in order to do chat for some reason, I think.
Right, yeah.
I was trying to get to the bottom of that because I couldn't do chat from this machine. But I got it from the other one though, so it's fine.
Yeah.
So, but yeah.
I think even if you're a co-host next time, it works the same way.
You what, sorry?
If you're a co-host even next time.
All right.
But I don't know why you can't get access to the chat, because I can get access to the chat.
Yeah, because I should have, shouldn't I? Should just
yeah,
be shouldn't it?
If you go to, tell you what, if you go to the more button, is there a chat button?
I looked at more earlier, but there's no chat there either.
I can't.
A bit weird, isn't it?
Yeah,
well, it's not a big deal because I just use the other computer, but it's just a bit of a pain because you go backwards and forth, and you can't see the messages either. Well, you can just.
Oh,
normally
Nick, at the top there in the big orange bit in that drop down, it says chat. Can you click on that? It opens it.
Oh, it's up there.
But it's tiny, so if you click on it, yes.
Yeah, that will open it. I didn't see it.
You're usually looking for the symbol. No, it's grand.
I was looking at the options. That's an option, but it's. Yeah, there it is.
Yeah. Perfect. Then the problem is everyone can see your messages, so if you're writing them individually.
Yeah, that's fine.
We're all learning here, huh?
I know.
Yeah. Okay.
Perfect.
Great.
Okay. Well, thanks everyone.
Yeah. All
That's
right.
good.
See you
Thanks,
then.
Nick.
Bye bye.
All right. Thank
See
you.
ya.
Bye.